Hello friends, this is Yusuf here. Today in this video we're gonna do something different. Okay, so we're gonna learn something but by doing some experiment. So we're gonna see how the subroutines versus sub procedures works. Okay, and we're gonna see which is faster by going to do some kind of experiment. Okay, so let's get started. Okay, many people know about subroutines, right? We'll be having many subroutines inside the program. We'll be splitting the code into different subroutines, and we'll call subroutines using EXSR opcode. Okay, execute subroutine. But at the same time, this can be replaced with sub procedure. Okay, but sub procedure is a ILE concept, and sub procedure is more powerful than subroutines, and natively sub procedure will run faster than subroutines. That's what everybody says in theory, but let's practically check it out. Okay, so what I'm going to do, I'm going to take F6 and I'm going to have RPG01 RPGLE. So I'm going to create two programs. Okay, that is going to do the same thing, but one with subroutines and another with sub procedures. Okay, let me quickly code that. Okay, the idea is we are going to have a log file. Okay, that's a flat file, and we are going to write simply the timestamp. Okay, and for writing the timestamp I am wantedly having it two subroutines. Okay, one is like a get timestamp and another one is a write. So get timestamp is nothing but we'll be getting the timestamp value in a variable, and write is nothing but the timestamp value will be converted to a character, and then we'll write that in a PF. Okay, so I just declared these two subroutines. So if you want to code it, it will be BGSR, begin subroutine, get TS and SR. So inside that, what I'm going to do, I'm going to say TS is equals to timestamp. So basically this TS we need to define it. Okay, and if I just copy this, okay, and it's going to be, let me see, this moves to move above. Okay, so the next one is the write. Okay, and here what we're gonna say, log data is equals to character of TS, and then we say write log fmt. So I had to create the files, but I'm just defining it. Okay, so basically now what we need to have here is TS, that should be a variable of length 26a. Okay, we should have this as a timestamp. Yes. So now we are going to have a file that is called log file. Okay, and that will be if file addition a external disk format. Now we need the file to be created. So I have created the log file, and we say this will be log fmt, and this is log data. Okay, so this is the file. It's a single field. Maybe you can have log file. So log file is the file which we have. Log fmt is the record format. Log data is the field. So with that, we have the log file here. we have mentioned this as append mode, so we can write it, and in the get TS we are just getting the timestamp in the TS variable that is declared internally. Okay, so this is not ready, it's a timestamp. And then in the write routine we have the timestamp converted to character and then stored into the write log fmt. Okay, fine. So let's RPG. Okay, so now let's compile this log file in qterm temporarily. Okay, rpg01 also in qterm. Okay, code is compiled. So if we call qterm rpg01, we should be able to see the timestamp in the log file. Okay, so now what we are going to do, we are going to do the same with sub procedures. So for that I am going to copy this program into another program. So to file space rpg02, if you give file space rpg02, the same program will be copied into rpg02. Okay, and here we are inside rpg02. Okay, fine. So now what we are going to do, we are going to replace these subroutines with sub procedures basically. Okay, so I will explain from this program itself. Okay, so if you have a sub procedures in program, you have to call using call p command. Okay, because it's a call procedure, fine. But if you have a procedure, first we should declare it, which means I have to say here my get ts therefore it's a PR. Okay, my get ts is a PR, and my write is also a PR. Okay, simply. And then we have to write the procedures. So writing the procedure is nothing but where we are writing the subroutines. So here we have written the subroutines, right? So using BEGSR, those stuff. But in this case, the procedures will be started with P. Like how we have a D and C, we have a P specification, and get TS. If you take F4, it can be a B or E, begin or end. So begin procedure. So we just gave P procedure begin, then copy this, and then here it's end. Okay, and inside the procedure we do not need to give the begin subroutine, end subroutine. Okay, done. So that's it. So this is the replacement of the subroutines to procedures. So similarly we'll change the other things as well, which is if you come here, let us copy this, paste it here, and change it to write. Okay, and then copy this, paste it here, change it to end, and then let's remove this, Okay, cool. So this is the similar program but replaced with sub procedures. Okay, but if I compile this, I'll be getting an error. I'll tell you upfront. Okay, we'll be getting an error. So the error will be something like the default activation group, okay, cannot be used. Okay, default activation group must be specified. Okay, I'll tell why. Many people will think that if we create a program in RPGLE, which means we are writing an ILE program, but it is not. Okay, so if you want to use the ILE concepts, what are the ILE concepts like activation group, procedures, sub procedures, modules, service programs, etc., we should not run in a default activation mode. That is the thumb rule. Okay, so here if you see in RPG01, we didn't specify anything, which means it runs in a default activation group, which means it is a OPM program, not ILE program. Okay, so now here we have used a procedure. As soon as when we use a procedure, it becomes it is using the ILE concept, then we should run in ILE mode. So which is nothing but the first rule of this is default activation group should be turned off. Okay, and if you specify this line, then the compiler will know that okay, this program is not a default activation group program, which means it's ILE program. Okay, so file. So now it should work. Qterm. Okay, this is nothing but okay, so there is nothing but parenthesis required for the procedure name. So this is nothing but when we want to call that, we cannot call like this. It's a procedure, we have to call with parenthesis. Okay, so this is because the sub procedures can accept the input parameter and can return the value. Okay, subroutines cannot, but sub procedure can. So we can tell something like okay, sub procedures are like programs inside the program itself. Okay, it can accept it can have its own variable, it can accept the input parameter, then it can return you the parameter, those things we'll see in the next videos. So now let us consider this as our basic program, which is using sub procedures instead of subroutines. Okay, so if I compile this, done. So if I call RPG02, it should work, and our log file should be having the second record. Okay, now how we are going to test the speed of it? Okay, I'm going to call the program like 10,000 times. Okay, and I'm going to see which one runs faster. So it sounds interesting, right? So I'm going to have another program now on top of these two, and then from that program I'm going to call each programs how many number of times I want, whatever. So let's see how it works. Okay, so this is my new program called RPG03, and it is having one variable called I, it's for counter. Okay, and again I have declared the other two programs as procedures. Now you can see that the program name is different, but using the extpgm keyword we can have equivalent meaningful name we want inside the program. Okay, anyway, so we are having this is how we'll call the other programs via the procedures concept from RPGLE. So here what I'm going to say, for I is equal to 1 to, say for example, 1000. Okay, and let us do n4. So similarly I will do okay, so similarly what we are doing is we are calling the program 1000 times basically. Okay, each program, and whenever we call the program, that file will be returned with the timestamp, and we'll see how much it takes to write the timestamps. Okay, that's it. So compile it, done. So before that, what I'm going to clear pfm qtemp log file. So I'm clearing the file, and then I'm calling RPG03. Okay, it's done. So if you go to STRSQL, select star from log file. So we are seeing a bunch of timestamp, but how do we identify which one belongs to what? So we called both the programs 1000 times. So if you give rrn of a comma a dot star, we should be able to see the RR number, and obviously it will be having 2000 record. First 1000 belongs to the first program, second 1000 belongs to the second program. So what I'm going to say, okay, I'm going to filter from RRN of a greater than equal to 1000. This will give me the 1000 record and 1001 record. So let me copy these two, okay, and put in a notepad, and if I come to bottom, this is the last record. Okay, paka. And if you want to see the first record, this is my first record. Okay, so what we are seeing here, so from 32nd 139 to 33 667, which means in 32nd, after 33 second it ran for 667 millisecond, and in the under 32, let me open a calculator. Okay, 1000 minus 139, okay, 861. So it took 861 millisecond. Okay, so on the total it's 861 plus 667 equals to 1528. So it took 1528 milliseconds. So here okay, we have a 34th second having full 1000. Okay, 33 we have a 669. From 669 means 1000 minus 669, which is 331, and then the 35th second it took 146. Okay, so if you want to add 331 plus 1000 plus 146, right, 331 plus 5, 146, 147. Okay, so what we see here is not so much difference, but we see the sub procedures run faster. But actually the experiment what we have done is how many times we call the program. Okay, we have called the program 1000 times, but each time when we call the program, that is executing the subroutines or subprocesses only once. You know the difference, right? So now what we are going to see, we are going to do it in a reverse way, which means we are going to call the program only once, but inside the program we'll run it 100 times. Okay, so here I'll remove these two because I'm going to call for only once. Okay, file, and then here is the beauty. So here what I will say, yes, here for I is equals to 1 to 1000, so similarly, yeah, that's it. So this for this program file, and if I go to this program, I'll do the same. 1 2 okay, and we should declare this I. So let me, so I is a s variable having yes. Okay, file, and here also we should have the I. Okay, now compile all the three programs. Okay, cool. Now what we're going to see, we're going to clear the file. Where is it? I'm going to call this program. Look how fast it runs. That's it. Okay, it's not even a second. Okay, so if you see here, okay, maybe I can see I can show you the whole file. So the first timestamp itself is this one. Let me put it in a pad. Okay, and the ending timestamp is this one. You can see all the 200 calling is ran on the 17 second itself. So this is not our experimental, but I'm just highlighting you. If you think like, okay, calling a program 1000 times to write the data is equals to calling the routines 1000 times inside the program, it's wrong. Okay, because when we are calling a program, it takes time to initialize the variable and allocating some space, those stuffs. Okay, so just information. Fine, so let's come back to our actual analysis, which is subroutines, subprocesses. So now what we have done, we have called the two programs, and each program is running its own code 1000 times, which means the program A was running 1000 times the subroutines, and program 2 was running 1000 times the subprocedure. But instead of measuring this, right, this 1000 call stack is not fine. That's what I say, because everything is happening within a second. So I'm going to increase the range. Okay, so which means simply I'll be so here let us put this as 10,000. Okay, 10,000 block file, and here also 10,000. Okay, and I have one more job to do, which is nothing but the log file. I have compile it normally. It will have only 10,000 records, so I will compile it with no max, because we will exceed 10,000, correct? Fine. Now let's call this program. Clear. Call. Wow. Oh, something happened. We didn't compile. Okay, RPG. Okay, clear, call. Okay, even then I can see it's very fast. You can see we have the 20,000 records, but anyway, so let's measure this. So I'm going to copy the values. The first one is this one. Okay, and the last one is this one. Okay, so in between we have r or not is greater than equal to 10,000. So this is 10,000 and this is 1. Okay, let's copy this. Okay, let me put the same calculation here. Okay, so what we see here is the first program took 174 milliseconds. Okay, 174 milliseconds to complete, and the second program runs 136 milliseconds. So we can see a fair number of difference. And okay, so from here we can conclude, okay, sub procedures are natively running faster than subroutines, and obviously we are having very small code, right? So we didn't see much difference. But when you're going for a complex program and many subroutines or sub procedures logic inside, and it's good to have the sub procedures. Even for the smaller things we can have sub procedures, because that is how the power of the ILE comes into picture. So okay, we can conclude, yes, it's true, sub procedures are running faster than subroutines. So I hope you will be start using the sub procedures if you are not doing it already, and I hope you enjoy the video. So I'll see you in the next video with another concept. Until then, thanks for watching. Bye bye.